Hello, my name is Meena Morrish. Today I would like to talk to you about how to use generative AI in increasing the efficiency of a knowledge worker, particularly within the financial services industry. Before we go into that, a brief introduction about what I do in AWS. So I'm a trusted advisor to customers. As part of the role, I provide them with insights and consultancies to help realize their goals and ambitions for the organization. I'm also an account CTO. So in AWS, we have got different types of solution architects. We've got an account SA, specialist SA, partner SA. So I am part of the team of account SAs that work with our financial services customers here in the UK. As part of that role, I help them define their strategy for AWS, consume it in a scalable, efficient way, but also make sure that they have the right access to the right AWS teams to help realize those strategies. I also play the role of an industry specialist, so I shine the spotlight on AWS capabilities that helps provide solutions for industry-specific use cases. I'm also a member or an aspiring member of a number of TFCs. So TFCs are what we call technical field communities, and we choose a technology or a domain to deepen our knowledge in. So I'm part of the IoT TFC, and I'm currently also working to become a part of GenAI TFC and the financial services industry TFC. So if you are in the tech industry, you will have come across this latest buzzword, which is generative AI. A recent economist intelligence study suggested that 85% of FSI leaders plan to use generative AI in product or service development. AI is already powering a number of applications within FSI to increase efficiency, enhance analysis, or deliver personalized experiences. The product and service development aspirations breaks down broadly into 4 different use case categories. The first one is around improving the customer experiences. So by providing hyper-personalized, contextualized responses to customer communications, or by enabling your customer service teams to get to that hyper-personalized and contextualized responses, generative AI enables the organizations to do this with a much more increased accuracy and efficiency. The second category is around increasing the efficiency of knowledge workers. So knowledge workers are typically people who perform the roles of, say, an investment analyst or data scientist, performing tasks such as providing investment research or responding to RFIs or creating regulatory communications itself. Generative AI helps them get to the product required much more quickly and efficiently and accurately. This previous use case category is something we will delve deeper into as we go through the sessions. The third use case category is around understanding market and customer sentiments. So where previously tacit knowledge was available across sources such as social media or forums or marketplaces, solutions built using generative AI is now able to obtain information from these tacit knowledge sources, but is also able to generate insights from those tacit knowledge sources, therefore giving a real insight into what is the market sentiment towards a particular product or a particular trend, or even understanding what is that particular customer's sentiment towards the brand based on their recent interactions or the ongoing interaction, providing near real-time insights to your customer service teams. Having this insight enables the customer service teams to adapt and tailor the approach, not just to where the customer is on the journey, but also their sentiment towards the brand itself. And then the final category is about building new products and automating business processes. So by by using generative AI, organizations are now able to build structured data products from a very vast size of unstructured data sets. And these data products then help inform the innovation teams or the product teams to provide information such as how is a particular demographic going to or expected to respond to a product or service offering that the brand is intending to release, or how are they already responding to an existing service offering or product, therefore indicating what adaptations that those products might need to take. But all these are generative AI, and generative AI is the latest evolution in a long line of evolutions in AI and ML. AI and ML is not new to the financial services industry. The foundational level in AI ML is a simple machine learning model. A simple machine learning model is something where it's able to take consistent, simple inputs, apply logic to it, and produce consistent, simple outputs. So in the financial services industry, use cases such as automated customer verification, where your customer but previously, they will have had to reach out to your contact center or visit a branch to prove their identity, are now able to apply or upload the stipulated set of documents, which is then processed automatically using a machine learning model, and it provides a consistent output. In this case, is it verified or not? Now, the next iteration of this evolution is deep learning. The main difference between machine learning and deep learning is the layers of neural networks. Neural networks is the core concept behind AI and ML. And it's quite similar to the neural networks that humans have in their own brain. So the main difference between a basic machine learning model and a deep learning machine learning model is the layers of neural networks. For a deep learning model, it has to have at least 3, if not more, layers of neural networks. Now, what that enables the model to do is to deal with complex input types but still produce simple output types. So again, in the financial services world, organizations are able to leverage this deep learning model capability to transcribe a voice-based customer call into a text and use natural language processing to obtain insights on that particular communication, and then apply machine learning model to identify the sentiment of that particular communication itself near real time. So your contact center team is able to adapt their approach and understand where the customer is coming from, how they are feeling emotionally as well. And then finally is the latest iteration of the evolution, which is foundational models. Now, foundational models have got a much more deeper levels of neural networks, and they operate with billions of parameters. With the use of extensive computational resources, you're able to train your foundational model to use a vast amount of data set, and the training or the pre-training of the model takes months at a time. But what this enables the models to do, combined with the very complex neural network, is that they are able to mimic human-like thinking and human-like logic. So as we saw in the previous slide, we discussed about the various use case categories where these foundational models are being applied. So another example would be insurance underwriting or claims processing, where foundational models are used to expedite those processes within the financial services industry. Artificial intelligence, whilst used almost synonymously with machine learning, is the technology that underpins all these tech categories. So artificial intelligence is a tech that mimics the ability to think like human brains. So What is the main difference between a foundational model and other machine learning models that we have? A traditional machine learning model operates using labeled data. So you train a machine learning model on labeled data to do a specific type of task. So as you can see, you can train a model to perform text generation, or you could train a model to perform information extraction or act as a chatbot, but they will need to be trained with very specific labeled data. For example, to do text generation, they will need to be trained with the various type of text they are about to encounter, and also what those text types are called and how to generate them. So the models then apply the logic or automatically based on that labeled data and are able to perform that particular task only. Whereas a machine learning model, a foundational model is trained on vast amount of unlabeled data. So when I say vast amount of unlabeled data, imagine all the online books on the internet, for example. And they are able to adapt their thought process to suit the task that is being given as a prompt by the end user. So if an end user is giving a prompt for text generation, even though they haven't been trained with a labeled data or data set to perform text generation, they are able to adapt themselves to produce that particular output. Where does generative AI fit amongst all these things? So to reiterate, artificial intelligence is any technique that allows a computer to mimic human intelligence. So it uses logic and if-then statements and other machine learning algorithms to provide that intelligence. Using that intelligence, the fundamental model is that traditional machine learning simple models. So that uses labeled data to perform automation at individual steps. So again, the typical use cases would be credit rating or customer verification. The next level of learning uses layered neural networks and deploys deep learning and is able to perform slightly more complex tasks such as personalized investment recommendations or processing claims or processing documents. And then finally, generative AI. Generative AI is powered by large language models, also called as foundational models, and is able to generate content like humans, and it produces content that doesn't exist previously, and hence the name generative AI. So far, we have discussed the application of generative AI broadly within the financial services industry. What are the various levels of evolution that generative AI tech has embarked on to get to where it is now? Let's now talk about how we can apply generative AI capabilities into a specific example within the financial services industry. So the example I have chosen is one of producing an investment analysis report. So the end user will be a knowledge worker who is an investment analyst in an investment banking firm, and is targeted with producing a recommendation for investing in the top 10 green energy organizations within the UK. Before we look at how we can employ generative AI to expedite this particular process, let's just quickly discuss what are the typical steps the analyst will have to follow. So obviously, they will have to access all the financial data, market data, and individual company data. They would then need to analyze all of this data. And the industry itself performs some quantitative analysis, risk assessments, and stress test before making a recommendation. So as you can see, when I explained, the analyst will have to go through very diverse data sources, pull in the right data required, and then perform manual analysis, apply all of the perspectives required to produce the various outputs, and then combine those individual outputs into a recommendation of an investment analysis report. How does this look like when we employ generative AI? Let's talk about the conceptual architecture first, and then we will talk about how we can realize that architecture on our AWS ecosystem. So conceptually, the first capability that the investment analyst would require is an application that they can interact with in natural language. So that means that it takes away the need for the investment analyst to learn any specific technology. The second capability we would require is a search capability that the interactive application can communicate with. The search capability will have the ability to trawl through the vast amount of knowledge base and index data from that knowledge base to be able to return search results back to the application capability itself. So far, we have managed to get define the capabilities required to get the input from the end user, pick up the right data required from a vast amount of data set available already. And now we will apply generative AI using a large language model. And this is where the real expedition happens, because where previously we discussed the analyst having to go through the various amounts of data set, putting those perspectives together and producing those individual outputs, and then merging those individual outputs into a recommendation report, all of that is done automatically using the large language model. Now, one could ask, well, this is a regulated industry. I've heard about hallucinations from foundational models. How are you preventing that from happening? Well, there's two ways we do that. One is we use something called as retrieval augmented generation. What this capability means is that we will train the model to generate responses only based on the data set that it has access to. So in this architecture, that will be the knowledge base. And we can then fine-tune the model for specific use cases. There are various parameters that you can change, like temperature and top K, to fine-tune the model to perform at its most optimum level for the particular use case in question. And then the large language model returns the result back to the application capability, which is then presented back to the investment analyst. So all those work that might take days, if not weeks, for the investment analyst to pull together has now been presented to them within a matter of minutes. One thing to remember is that this does not remove the need for the investment analyst, nor does it negate the skills that they require. It simply makes them exponentially more efficient. I heard one of my colleagues say internally, which I thought was great, is that spreadsheets do not remove the need for an accountant. So generative AI is not going to take away any of the roles or the responsibilities that those roles need to perform. It just expedites the way those roles are being performed. So what does the realization of this conceptual architecture look like on an AWS landscape? So in our AWS ecosystem, there are a number of services that you can pick and choose to realize the conceptual architecture. I'll now go through one of those ways to achieve that. So in the example of generating an investment analysis report, so your analyst will interact with Amazon Lex, with a prompt. Amazon Lex is a fully managed artificial intelligence service through which you can design, build, test and deploy conversational style applications. And you interact with Amazon Lex using something called as a prompt. So a prompt is a set of instructions provided to the application in natural language. So in this example, a prompt could be provide me with a summary of financial data of the top 10 green energy companies operating within the UK. So when the investment analyst enters that prompt in Amazon Lex, let's see what happens next. I've chosen Amazon Kendra for our search and indexing capabilities. So Kendra is our intelligent search service. It is powered by machine learning itself and natural language processing. So with those capabilities, Kendra is able to take the search queries in natural language and is able to retrieve the right search result from the data set that you are asking it to perform the search on. How does that do that? It does that with two main features. The first one is connectors. So a typical enterprise organization tends to have its data spread across different sources like websites or knowledge management repositories like SharePoint or Confluence. So the connectors on Kendra enables easy integration with these diverse data sources so that they can parse the data and create an index. So once they parse the documents, what they do is create indexes. Indexing is a way to host the location of specific types of data or data sets so that when Kendra receives the search query, it's not trawling through the entire data set to find out where the data is. It will just go through the data indexes to know which part of the data set it needs to search, therefore making the performance of the search query much more efficient and much more quicker as well. So now that Kendra has retrieved the relevant financial data of the top 10 green energy organizations, it will send that back to Amazon Lex with the search results and the relevant document excerpts. What does Amazon Lex do with that? We still haven't gotten to the initial version of the product we require, which is recommendation of an investment report. And this is where the generative AI comes in. Lex needs a service to communicate with to generate that initial report for it. And that will be done in this architecture using Amazon Bedrock. Amazon Bedrock is a fully managed AI service which provides access to customers to both Amazon's proprietary large language models like Amazon Titan and also other third-party models such as Anthropic's Claude or Meta's Llama or Stability's Diffusion. What this means to the customer is that they're not restricted by a single choice of foundational model. They are able to choose which model they want or suits better for each of the various use cases they have without any of the complex commercial or the operational overhead that comes with having diverse supplier portfolios. The other benefit that it offers is that you are bringing the model required to the data, which is a much easier and efficient way of doing it rather than moving the data to the model itself. So Amazon Bedrock can be fine-tuned and enabled with retrieval augmented generation to fetch data from the desired data set. Again, what I have shown here is to use the same knowledge base as what Kendra uses, but there is also a knowledge base feature within Amazon Bedrock itself. So customers have the flexibility to choose which knowledge base they want to use. So the model chosen within Amazon Bedrock will generate that initial report of investment recommendation for the top 10 green energy organizations within the UK. which will then be presented back through Lex back to the investment analyst itself. So again, a process without the power of generative AI would have taken weeks to get to this initial draft, whereas with generative AI has now expedited the whole process significantly and made the knowledge worker in question much more efficient. So far, we've sort of dived deeper into what this means for this particular solution, but what sort of outcomes do these deliver at an organization level? The first benefit it delivers is improved productivity. So one of our customers, who's a large global investment management organization and an insurance company, processes about 30,000 customer calls daily, but they could only analyze about 10 to 12% of the calls. So a vast amount of insights available in the rest of the communications were lost. So they introduced a solution using post-call analytics and Amazon Bedrock, through which they increased their productivity to analyze about 1 million calls. The second benefit that you get is increased accuracy. So one of our other customers, Edelweiss Tokyo Life Insurance, a leading life insurance organization in India, wanted to understand their customer needs better and identify the right policy or increase the accuracy of the policy they are recommending to the customer. And they did that by developing a cross-sell propensity model and a policy recommendation model in partnership with Amazon's machine learning lab. And then the final benefit we get is enhanced customer experience. So Jan Hancock, an insurance organization, was able to deploy an intelligence contact center solution that allowed their customers to perform automated benefits and claims status checks. So rather than waiting, being held in a queue for extended periods of time and then reaching the contact center agent and then going through all the verification processes again before getting to the outcome of finding out their benefits or claim status checks, they were able to do it in an automated way, therefore giving a much more better experience to the customers. The solution included Amazon Lex and Amazon Connect, and it pulled together information of the customer's previous engagements through very diverse channels as well. So along with making those, allowing them to make those automated status checks, they were also able to make recommendations on what relevant articles to peruse or what other relevant Jan Hancock insurance offerings to offer to the customer itself. I hope that was useful. If you want to learn more, I've got a couple of QR codes here. One is to learn more about the services and the trends of using artificial intelligence and machine learning within the financial services industry. Or if you're interested in understanding about the upcoming trends, or what does the future hold for generative AI in financial services, there's also the link to an on-demand webinar to listen to. Thank you for taking the time to watch this video today. I hope it was useful. Thanks.